Good day, everyone. We are from Group 3 and we are going to tackle about modern algebra and number theory. Modern algebra and number theory are the two oldest fundamental branches of mathematics that are at the very center of mathematics even today. The birth of algebra, as mathematicians knows it today, is also the birth of the axiomatic approach to mathematics. Now, let's dig deeper. What is really the modern algebra and number theory?
Modern algebra, also called abstract algebra, a branch of mathematics concerned with the general algebraic structures of various sets, such as real numbers, complex numbers, matrices, and vector spaces, and etc. So what exactly is modern algebra? It's a branch of mathematics that studies algebraic structures, which are sets of equipped with one or more operations that satisfy certain axioms. Think of it as a way to generalize and abstract the familiar rules of arithmetic and algebra. The development of modern algebra really took off in the second half of the 19th century. Mathematical advances led to the study of sets in which any two elements can be combined, added, or multiplied to give a third element of the same set. This was a shift from focusing on specific mathematical objects to studying the underlying structures themselves. So, one of the most influential figures in the development of modern algebra is Bartel van der Waarden, a Dutch mathematician and writer. Van der Waarden is best known for his book Modern Algebra, published in 1930. This book synthesized the work of Emmy Noether, Emil Artin, and others, and it had a profound effect on the way algebra was taught and researched.
Group theory, a part of modern algebra, studies group. A group is a set of things called elements, combined with a way to operate on the two of them at a time. This operation has to follow specific rules called axioms. So group theory explores what happens when you have a collection of objects and a consistent way to combine them. The group contains identity elements, which is a special member of the group that doesn't change any other elements when they are combined using the group operations. Think of it like adding 0 to a number. For example, 5 plus 0 still equals 5. 0 plus 5 still equals 5. So, for integers with additions, 0 is an identity. In general, there will always be an E or identity in the group, such that if you combine A with E, you'll always get A back. The group contains inverses, meaning in every elements, there's another elements that cancel it out when combined using the group's operations, resulting in the identity elements. For examples, in a group of integers with additions, the inverse of 5 is negative 5, because 5 plus negative 5 equals 0, which is the identity elements of additions. Mathematically, in every element A in the group, there exists another elements B in the group, such that A and B equals E, and B in A equals E, where E is the identity element. The operation is associative, meaning if you are combining 3 or more elements, the order in which you group them doesn't change the final result. It's like saying open parenthesis A and B, close parenthesis and C, as same as A, open parenthesis to B and C and close parenthesis. So whether you do A times B first and multiply by C, or you do B times C first and multiply by A, you will always end up with the same answer. The group is closed under the operation, which simply means that if you take any two elements from the group and apply the group operations to them, the result will always be another element that also part in the same group. For example, if you add two integers together, like 2 plus 3 equals 5, the 5 is the integers. These rules ensures that the operation keeps you inside the group. Évariste Galois is a French mathematician known for his groundbreaking work in group theory, a key part of advanced algebra. His theory solved a centuries-old problem, figuring out when a math equation can be solved using radicals, like square roots and cube roots.
Number theory is one of the oldest and most undergoing branches of mathematics. It's often referred to as the Queen of Mathematics, a little given by Carl Guss, who himself was known as the King of Pure Mathematics. This branch of pure mathematics is dedicated to the study of natural numbers and integers. These are the positive whole numbers we use every day, like for example, 1, 2, 3, and so on. Let's meet one of the pioneers of number theory, Ferry D. Fermat, who lived from 1601 to 1665. Fermat was a genius who posed questions and identified problems that mathematicians are still exploring today. He made revolutionary contribution to various areas of math, especially number theory.
Number as a sum of fewer or fewer is square 1638 format as 30 terms. Whatever whole number you choose, you can get it by adding up to 4 perfect squares or fewer. A perfect square is a number that results from multiplying a whole number by itself. Example, 1, 4, 9, 16.
Example, 1 plus 1 plus 1 plus 4. Diba? 7. That is 4 squares. Another sample, 16 plus 4. Diba? 2 squares. Fermat started that there cannot be a right struggle wheel sides of integer lines whose area is a perfect squares. In other words, if you draw a right triangle where the sides are whole numbers, integers, it's impossible for the area of that triangle to be a perfect squares like 1, 4, 9, 16.
Prime number theorem. Designate the number of primes less than or equal to n by pi of n. Thus, pi of 10 equals 4 because 2, 3, 5, and 7 are the 4 primes not exceeding 10. Similarly, pi of 25 is equals 9, and pi of 100 is equals to 25. Consider the proportion of number less than or equal to n that are prime pi of n over n. Table of illustrating the prime number theorem using selected values of n, ranging from 10 squared to 10 to the power of 14.